Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of TypeScript enums. We'll explore their functionality, practical applications, and compelling alternatives. Get ready!
I'm pumped. So, TypeScript enums. What's the core idea? Are they just glorified constants?
Not exactly. They're more than just constants. They define both an object, mapping keys to values, and a type, restricting values to only those defined within the enum. Think of it as a custom type with built-in validation. Pretty neat, huh?
I see. Interesting. So what are some real-world scenarios where enums shine? Give me some examples.
Absolutely. One key use case is creating namespaces for constants with primitive values. Imagine representing file access modes in Node.js, read, write, execute. An enum neatly encapsulates these, allowing for bitwise operations. But an object literal could work just as well there.
Right, bitwise operations. Makes sense. But what about situations where you need a custom type with strictly defined, unique values? Like, say, different user statuses. Active, inactive, pending.
That's another perfect fit. Enums excel at enforcing type safety for these kinds of scenarios. You get compile time checks ensuring only valid statuses are used. However, string literal unions offer a simpler, albeit less type-safe, alternative. And you can even use object literals with symbols for enhanced type safety.
Symbols? That sounds advanced. What's the advantage there?
Symbols guarantee uniqueness, preventing accidental collisions. It's a bit more verbose, but it provides a higher level of type safety. It's a trade-off, you know?
Got it. Now what if I need a namespace for constants, but these constants are objects, not just primitives? Can enums handle that?
No, that's where enums fall short. For constants that are objects, you'd typically use object literals. You can even create a discriminated union using a key property within each object to enable exhaustiveness checks. Or you could use an enum class, which allows for methods but sacrifices exhaustiveness checks.
So it's all about choosing the right tool for the job. Enums are powerful, but they're not a one-size-fits-all solution. What about mapping to and from enums? How does that work in practice?
Excellent question. You can use a map to map enum values to other representations, like strings for JSON serialization. And, importantly, TypeScript can help you catch errors if you forget to map a value. This is especially useful when dealing with symbols.
That's clever. So to summarize, enums are great for namespaces of primitives and custom types with unique values, but object literals or enum classes are better suited for object constants. And the performance of string-based enums might be a consideration for large-scale applications.
Exactly. Remember, TypeScript enums are a TypeScript feature, not a JavaScript one. This impacts transpiled code and tool compatibility. Choosing between enums and alternatives depends heavily on your specific needs and priorities. Weigh the pros and cons carefully.
This has been incredibly insightful. Thanks for breaking down the nuances of TypeScript enums. It's clear there's more to them than meets the eye.
My pleasure. And remember, listeners, stay tuned for more Tech Bytes and News. We'll see you next time. Goodbye.
Bye-bye.